Hey guys, we did this activity in class to help us get another example of direct variation. So we, in class, worked through which of these were or were not direct variation. Some were not. And then we worked out this graphic organizer on direct variation. So if you missed class, make sure you get the notes from me or someone else. And here was the homework assigned. So it says, let's zoom in. At the top here, these are the learning objectives, right? And here's what they were asking for you to understand after the activity. So it says, one of these scenarios represents direct variation and one does not. How can you tell the difference? Okay. So using this graphic organizer, right, we found out that direct variation is only when you multiply. So it's when you have some kind of an input value and you multiply by something that we called a multiplier. And then we end up getting an output value. Okay? Now, we're looking to see if we are going to get the same type of a question as some of the ones we did before, like the speedometer, where we did miles per hour and kilometers per hour, right? Our scale, which was pounds and kilograms, right? Or our scenario here where we had the square and we converted the side of the square in centimeters. And there was a conversion that we could then multiply it by 1.4 to get the diagonal length in centimeters, okay? So now with that said, let's take a look at A and B and see if they make sense with what we've talked about here. One of these scenarios represents it and one doesn't. A large pizza with one topping costs $15.50. Okay, so topping, and then this is cost, right? $15.50. A large pizza with 4 toppings cost $20. Does the price vary directly with the number of toppings? Okay. So we noticed in the earlier lesson, if we had the 1, we could say to yourself, well, I know if I put 1 in and I multiply $15.50, I'm going to get $15.50, right? But I notice here if I put 4 in and I multiply by the same multiplier, I'm not getting 20. I'm getting a number a lot bigger than that. So 4 times $15.50, if I go to my calculator, 4 times $15.50 is 62. So it doesn't look exactly like the ones we looked at before. So now let's look at the marathoner. So it says the marathoner ran 5 miles in 40 minutes and 15 miles in 120 minutes. So let's break that down. So kind of trying to draw the same analogy here. If I put in miles, 5 miles, and then I end up getting minutes, 40 minutes, then would I get 15, 120? Now, I think this one looks like a yes, right? If I count by 5s, 5, 10, 15, and so each time I'm adding 5 and I'm adding 5. Here, if each time I have 5, I add 40, add another 40, I get 120. It looks like this one is direct variation. And this one is not direct variation. So again, I didn't have the benefit of having 1, but I could get it. If I could say to myself, well, 5 miles as an input times what multiplier would give me 40? So if I'm trying to solve this, I'll call it x. Notice I can divide by 5 on both sides, and x, or my multiplier, would be 8, right? So let's see if this works. Is 5 for an input value times 8 equal to 40? Yes. Is 10 times a multiplier of 8 equal to 80? Yes. So is 15 an input times 8 equal to 120? Yes, it is. So this one is definitely direct variation because I'm using the same multiplier, 8. Notice here, this is 1 times, I'll use a different color, 1 times 15.5 would equal 15.5. This is 4 times 5 would equal 20. Here, it's different multiplier. Nice job, guys. Thanks for joining us.